Hello everyone, we speak about wastewater to save irrigation. So we have here introduction to circular water economy. According to global freshwater security, driven by rapid urbanization and shifting climate pattern, has turned treated micable water into critical asset for agricultural irrigation. Agriculture accounts for approximately 20% of global freshwater withdrawal. Repurposing reclaimed wastewater offers urgent climate and adaptant alternatives that support food security and ease the strain on over-allocated natural aquifer. However, moving from raw mechanical discharge to sieve agriculture reuse require a strict multi-barrier treatment system. Wastewater contain a complex mix of biological pathogens, suspended soil, heavy metal, and emerging contaminants of concern. Without appropriate engineered intervention, applying this water directly to agricultural field risk soil degradation, crop contamination, and serious public health issue. Engineered multi-pore treatment trains to consistently meet stringent microbiological and physiochemical irrigation standard. Modern reclamation facilities rely on an integrated multi-stage treatment process. Biological oxidation following a preliminary grit remover, primarily sealing tanks, reduce heavy suspended load. The water then undergo intensive biological degradation using conventional activated sludge or high efficiency membrane by reactors, combine biological digestion with microfiltration or ultrafiltration membrane, providing an excellent baseline separation that removes nearly all suspended solids and significantly lower biochemical oxygen demand. Advanced tertiary filtration. Um, yeah, we have here pathogen disinfection dynamics. Disinfection is the primary part preventing foodborne illness. Reclaimed water must achieve high log reduction value for target pathogen. Ultraviolet radiation destroys the nucleic acid structure of bacteria and virus without generating harmful disinfection byproduct. Standard target dosage typically exceed 40. Ozonation, a powerful oxidizing agent that break down resin viral capside and micropollute stimulously. Chlorination provide a critical disinfectant residual within the irrigation distribution network, preventing biofuel and pathogen growth inside pipeline system. Agronomic risk metrics and the soil health. While reclaiming water provide valuable nutrients like nitrogen and phosphorus, its chemical composition must be carefully managed to prevent long-term soil damage. Soil salination and sodium adsorption ratio. High concentration of dissolved sodium relative to calcium and magnesium break down soil structure, sealing pores, and reducing permeability. This risk is evaluated using the sodium adsorption ratio. Irrigation water value greater than 9 require blending with fresh water or treating the soil with gypsum to preserve its structural integrity and prevent clay dispersion. Heavy metal accumulation limit industrial contribution to municipal wastewater network, can introduce trace heavy metal like cadmium, lead, nickel. Over time, these metals can accumulate in the upper soil profile and be absorbed by crops. Strict maximum threshold control are enforced to prevent toxic accumulation in bulk chains. Global regulatory framework reclaimed water regulations are structured around the intended end use, applying the highest restriction to crops that are eaten raw. Reclaimed water quality operation metrics. Target crop types, E. coli limit, turbidity, primary risk management. Food crops consumed raw, not detectable. Turbidity, advanced ultraviolet disinfection, mandatory drip irrigation to prevent direct fall, contact and routine microbial leaf sampling. Food crops consumed cooked or proceed, subsurface drip irrigation, strict pre-harvest waiting periods to maximize natural soil or pathogen die-off. Pasture forage and industrial fiber crops, restricted worker access during irrigation, buffer zone near residential areas, and livestock grazing deferral. Non-food industrial forest and seed crops. Fencing to prevent public entry, clear signals, and regular monitoring of underlying groundwater levels.